Problem number 1. The graph of the piecewise linear function f is shown. If g of x is equal to the integral from, that should be a 1, to x of f of t dt, find the following values. We're going to start off with g of 0. So g of 0, the first thing that I like to do is if I'm given g and it says that g is an integral, g is actually going to be the area under the curve. Okay, g prime, if I take the derivative of an integral, that's just going to end up being the curve or points on the curve. And then g double prime would be the derivative of the curve, which is going to be the slopes of the curve. Okay, so when I'm doing this, first of all, it asks me to find g of 0, and I guess all I needed were the areas under the curve for this one. Alrighty, so we're going to put in 0 for my x, so I'm going to find the integral, the area under the curve from 1 to 0 of f. We can't go from 1 to 0, so we're actually going to make this negative, the integral from 0 to 1 of f. So we're basically just looking for the area under the curve from 0 to 1. So when I do this, this is a triangle. It's going to be the opposite of whatever I get. It'll be 1/2 times the base, which is 1, times the height, which is 1, so I'll end up getting an answer of negative 1/2. The next thing asks me to find g of 1, so this would be the area under the curve from 1 to 1. Well, that covers no distance, so the area is going to be 0. The next one, g of 2, would be the area under the curve from 1 to 2 of f. So if I go from 1 to 2, it's going to be this part right there. It's just going to be 1/2 times the base, which is 1, times the height, which is 1, which will just be a positive 1/2. G of 3 will be the area under the curve from 1 to 3. So if I'm finding the area from 1 till I get to 3, and although this is not necessarily drawn to scale, I can tell that actually those two are going to cancel each other out. So I'm going to get an area of 0. And then g of 4 is going to be the area under the curve from 1 to 4. Well, I knew from 0 to 1 to 3 is 0, so I just now need to calculate the area from 3 to 4, and it's underneath the x-axis, so it's going to be negative 1/2. The base is 1, the height is 1, so this is an answer of negative 1/2. Okay, and then from here, we would like to find which of these values, so that was part A, and then B, which of these values is the greatest. So I just look at which one gave me the biggest answer, and I'll just say g of 2 is the greatest. And if I had to justify my reasoning, it would be because that answer was 1/2, and that's bigger than all the other answers. Right, number 2, if cosine of 3xy is equal to x squared, then dy dx equals what? So we are going to be finding the derivative, and since there's an x and a y involved here, we will be using implicit differentiation. And since there are parentheses, we actually are going to be doing a u substitution. All right, the derivative of cosine u would be negative sine u times du. And the derivative of 3xy, we actually get to use the product rule for, so I'm actually going to come over here and do a little side trip. If f is 3x, f prime is 3. If g is y, g prime will be 1 dy dx. All right, so using the product rule for this, it's going to be sine of u times du, which is in this case going to be f prime times g, so 3y, plus f times g prime will be 3x dy dx. Okay, and then I'm just going to replace my u back in, so this is going to be negative sine of 3xy times 3y plus 3x dy dx, and then equals the derivative of x squared is 2x. All right, if I would like to solve for dy dx, I need to, first of all, divide both sides by negative sine 3xy. So now I'm going to be left with 3y plus 3x dy dx equals negative 2x. And since this really is 1 over sine is equivalent to the cosecant, so I'm actually going to change that to the cosecant of 3xy. And then from here, continuing to solve for dy dx, we'll subtract 3y from both sides. So I will get 3x dy dx is equal to negative 2x cosecant 3xy minus 3y. and then my last step would be to divide by the 3x. So dy dx will equal negative 2x cosecant 3xy minus 3y all over 3x. All right, problem 3. The graph of the function f is shown for 0, x is between 0 and 4, of the following, which has the least value and the greatest value, and explain. Okay, for part A, the integral of f of x from 1 to 4 would actually mean it is the true area under the curve, so we'll just keep that in mind. All right, for part B, and I'm just going to put that was in purple. I'm going to change my colors. For B, I'll use red. The left Riemann sum with 3 subintervals of equal length. So we'll draw 3 rectangles, and they need to start from the left. So they'll start from the left and work to the right, start from the left, work to the right, start from the left, work to the right. And so you'll notice that approximation ends up being a little bit over the curve. So this is definitely greater than A so far. All right, I'm going to switch my colors again. Okay, this time I'll be using blue. And let's see, this time we've got a right Riemann approximation with 3 subintervals of equal length. I'm not sure how I got this crazy little thing here. Let me try this again. All right, much better. All right, so we're going to start at the right and work to the left. So here would be my first rectangle. Here's my second here's my second rectangle. And here is my third rectangle. So you notice on this one, this ends up being actually less than A, and actually it ends up being less than B as well. All right, let's try midpoint sum. Midpoint, I'll let be green. Okay, if I do a midpoint sum, halfway between, let's see, halfway between 1 and 2 would just be right here. Halfway between 2 and 3 would be right there. Whoop. This graph's getting pretty messy, but we can do it. Okay, so you'll notice I get some in and some outside. I'm pretty close to the A, so I'm just going to say it's getting close to A, but it's definitely not as big. It's not as big as B, because B is going way over and that one's going over, but then it's also going under. Not bigger than B. Alrighty, and then E, the trapezoidal approximation. Right, a trapezoidal approximation, remember, will connect the 2 endpoints, and then we'll make trapezoids. We'll connect the 2 endpoints and make trapezoids. We'll connect the 2 endpoints and make trapezoids. So notice that one's very close to the actual area, which is the area of A. So this one is asking us which one has the least value and which one has the greatest value. For sure, the greatest value is going to be the left sum. I'm going to put this one would be the left sum, and when it asks us to explain, when we did the left sum, because this was a concave down graph, my rectangles all ended up being over the actual area, so I got an answer that was an overestimate. And then for actually that was the greatest value, sorry about that. And then the least value, if you look at it, the one that ended up having a lot more underneath left over than any of the others was the right sum, so C would be the least value. And again, that would be probably, I would say, because the left sum gave me rectangles that were underneath, so there was a lot of area left underneath the curve untouched. Right, number 4, the graph of the function f is shown. Draw a possible graph of f prime, the derivative of f. So first thing that I'm going to do is attempt to make an f prime chart. And if this is a picture of f prime, I'm going to be looking at where this graph is increasing and decreasing. I'll be looking at the slopes. So this graph is going up, or it has positive slopes until I get to -3. And then between -3 and -1, the graph is going down, so it has negative slopes. And then from -1 until I get up to x equals 2, the graph is going up, so it has some positive slopes. And then after 2, the graph is headed down, so f prime would be negative. So from here, if I have f prime, and I now would like to draw an f prime chart, f prime graph, so f prime chart to an f prime graph, we're going to just be looking at above and below the x-axis. So at -3, it's going to hit the x-axis. At -1, it will hit the x-axis, and at 2, it's going to hit the x-axis. I'm going to be above the x-axis till I get to negative 3, and then I'm going to be below till I get to negative 1, and then I'm going to be above till I get to 2, and then I will drop below. So this would be a picture of what f prime might look like. Okay, problem 5. Find the solution to the differential equation dy dx equals x cubed plus 2 over 3y with initial condition y of 6 equals negative 5. The second you see the words solve the differential equation, hopefully what was blaring out in your mind were the words cross multiply. So that's exactly what I'm going to do. I'm going to get 3y dy is equal to x cubed plus 2 dx. I already have my variables on the right sides, so I'm ready to take the integral to get rid of the dy and the dx. When I take the integral of the left side, I will get 3 halves y squared. And when I take the integral of the right side, since there's a plus sign, I can take the integral of each part separately. I'll get 1/4 x to the 4th plus 2x, and don't forget that we do have to tag on our plus c. I would like to attempt to solve this for y. So the first thing that I'll need to do is multiply through by 2/3. So I'm going to get y squared equals, this will end up being 1/6 x to the 4th plus 4/3 x plus c. Eventually we will want to square root this, but before we square root it, I'm actually going to find the c first because I think that's easiest. So we know when x is 6, my y value is negative 5, so I'm going to have negative 5 squared equals 1/6, 6 to the 4th, plus 4/3 times 6 plus c. So I'm going to have 25 equals 1/6 times 6 to the 4th is going to give me 216, plus 4/3 times 6 will give me 8, and then plus c. So I will get 25 equals 224 plus c. Solving for c, I get negative 199. So I now have y squared equals 1/6 x to the 4th plus 4/3 x minus 199. And if I, to get rid of the square, I'll square root both sides. Remember, when we square root both sides, I do have to put a plus or minus. So I'm going to get y equals plus or minus the square root of 1/6 x to the 4th plus 4/3 x minus 199. But then remember, since I was given the initial condition y of 6 equals negative 5, I know that I have to get a negative answer, so I'm actually only wanting the negative square root. So my answer will be y equals negative square root 1/6 x to the 4th plus 4/3 x minus 199.